So, retrieval roulette for today, please. You will notice that I have gone back to all space. This topic is very factual heavy, like factual recall heavy, and the past paper questions are quite repetitive in it. So we're going to be focusing on it for a little while, okay? Just in our retrieval roulettes, just because it's very wordy. That's what I'm trying to say. Okay, so pause, get these answered, and then I'll give you the answers in a wee second now. Okay, there's the answers for you to mark and correct what you put down. Thank you. Okay, if you open up at page 246 for me, please, we'll go over these answers from last lesson. I was going to say when it was, can't remember, Friday. Okay, so to transfer electrical energy from the power station to my home, we could use either a low voltage and a high current, or a high voltage and a low current. First method is not efficient because the high current heats the power lines and wastes the energy. Method 2 is used, this one. To get the high voltage, a step up transformer is used at the other end of the grid. Near my home, a step down transformer is used. AC, alternating current, has to be used because transformers do not work with direct current. Right, question 2. So this one just goes through the whole process of producing electricity and getting it basically from coal or oil or gas to your home. So you were given all these and you had to put it in order. So here's my order here. So first of all, gas or coal is burned in air in the power station. Then that heat is used to heat water, which then makes steam. Then the steam makes a turbine turn. Then the turbine turns a generator. Then the generator produces electricity in AC. Then the voltage of that is stepped up to 132 kilovolts or more by a transformer. Then the energy is transferred through the national grid at this high voltage. Then the voltage is stepped down to 230 volts by a step down transformer. And then electricity is supplied at 230 volts to your house. Okay, over on to page 247. So number 5, why is electrical power transmitted in the grid at high voltage? It's so that energy isn't wasted as heat. So if it was a high current, low voltage, then the wires would heat up a lot, and a lot of that electrical energy would be wasted in the form of heat. So that's what I've tried to say there. And then I've put in P equals IV just to remind me to talk to you about how it's remember we talked about how the transformers are like really efficient. So the power in is going to be equal to the power out. So because power is equal to current times voltage, you can transfer the energy at a really low current and a really high voltage, and you're still transferring the same power as if it was the opposite way round. And a low current will mean the wires won't heat up as much and you'll not be losing as much energy. Right, 6A, what are the 3 essential parts of a transformer? So either one of these two, I suppose, so an AC power supply, or you could just have called that the primary coil, the iron core, and then the secondary coil. What's the purpose of the core of the transformer? To increase the strength of the magnetic field. And why must the core be made of soft iron? Iron loses its magnetism easily. Now, hopefully, I don't know if I remember to say, but hopefully you're marking and correcting these. 7, explain why a transformer will not work with direct current. Direct current is going to produce a steady magnetic field, and the secondary coil needs that magnetic field to be changing significantly to produce a current. So if you have your alternating current, which is constantly changing direction, then that magnetic field is always going to be cutting across that secondary coil to produce your current in that. Sorry, can't get my words out today, year 12. Right, 8. A step down transformer changes 240 volts, so that's our primary voltage, to 48 volts, so that's our secondary voltage. There are 2000 turns on the primary coil, so that's NP. Find the number of turns on the secondary coil, so NS. So remember, we can write this equation whatever way we want. Because I'm looking for NS, I write it up top left. Just makes the rearranging a wee bit easier. Make sure your S's are on the top line altogether and P's on the bottom line altogether, or the opposite of what I have just said. So NS over NP equals VS over VP. So NS over 2000 equals 48 over 240. 48 divided by 240 multiplied by 2000 will give you this value for NS. So it is 400. Okay, over the page to question 9. The diagram represents a simple transformer with 20 turns on the primary coil, which I've listed here, 80 turns on the secondary coil, which I've listed here. 4 volts is supplied to the primary, so primary voltage is 4 volts. What voltage would be the secondary? So this time, because we're looking for the secondary voltage, I have put it top left in my equation. So VS over VP equals NS over NP. Fill in my values. So VP is 4, so that's why that's going in there. NS is 80, so that's why that's gone in there, and NP is 20, so that's why that has gone in there. So 80 over 20, all multiplied by 4, gives you 16. Right, 10. The voltage across the power line supplying a house is 24,000 volts. What type of transformer must be used? I was being a wee bit passive aggressive in my answering here. I'm assuming this is talking about to the house, step down transformer to the house. Why is the supply not transmitted at 240 volts all the way? Well, that would mean that the current would be too high and then energy would end up getting lost as heat. These answers are quite repetitive. See, the 24,000 volt supply cannot be used unchanged in the house. Why not? Your appliances are just not going to work. Appliances are made to work at the 240 volts, and if you suddenly supply them with 24,000 volts, it's not going to end well. You're just going to wreck your stuff. Okay, part D then. How many turns are there in the secondary coil of the local transformer? So I've made this list of information from this diagram and the initial information. So in this case, our primary is going to be the 24,000 volts that it's getting transferred across the grid at. So in this case, our primary, like our input is here. Is this still talking about going to the house? Yes, it is. Sorry. So our primary is here and our secondary is everything to do with the house. So the voltage of the primary this time, 24,000. Voltage of the secondary is the 240. Number of turns in the primary, it was in the wee diagram, was 5,000. And we need to get the number of turns in the secondary. So because NS is what we're looking for, I've started top left with that. NS over NP equals VS over VP. Filled in my values. 240 divided by 24,000 and then multiply by 5,000 and you end up getting 50 turns in the secondary coil. Right, 11. An oil-fired power station produces electricity at 25,000 volts. This voltage is stepped up to 400,000 volts by a transformer. What type of transformer is used between the power station and the national grid? I'm happier with the way they've asked at that time. Step up transformer. And then B, the number of turns in the primary coil of the transformer is 10,000. I've listed that there. Calculate the number of turns in the secondary coil. So because it's step up, I know automatically like my answer has to be a higher number. So we're looking for NS. And these numbers here have come from either, I suppose, this initial blurb or from the diagram. So our primary voltage is 25,000 and our secondary voltage is 400,000. So I'm looking for NS, so I start with it, top left of my equation. Fill in my values. 400,000 divided by 25,000 and then multiply by 10,000 and we get 160,000 turns. Right, C. Why is a voltage as high as 400,000 volts used in the transmission of electrical energy? We have been asked this many times now. It's going to keep the current as low as possible so that we can still transfer as much power without losing all that energy. So it's the most efficient way to do it. Right. Now, I am going to give you some past paper questions on this stuff instead of doing those ones like the end of topic questions in your notes, because I think the past paper questions are more useful to you than those ones. So I need you to get those done for the rest of this lesson and we'll see how we get on with those. That's me. Okay, see ya. Bye.